Hello everyone. In this video, I'm going to go over the solutions to some practice problems for the test. So let's start with number 1. Explain the differences between a raw dataset and a clean dataset. Okay, so basically a raw dataset is in the exact same form that the data was collected in. That the data was collected in, whereas a clean dataset has been carefully edited to standardize all the entries. For example, you might fix typos, capitalization, mismatches, alternate names for the same thing, ways of saying the same thing, like, I don't know, one versus one spelled out, stuff like that. Why is it necessary to clean data? Okay, this is because data analysis programs like Excel need the data to be standardized in order to make things like pie charts, take averages. Imagine if you try to take an average and it's numbers that are spelled out instead of in digits. Like we can't average numbers that are spelled out. It's things like that. And it also makes it easier for humans to understand the data. Okay, what is an observation unit? This is probably the number one most confusing thing that's going to be missed on this test. There's actually a number of different words for this, but the one I have used is observation unit. This is something that you're going to take measurements from. It's not the measurements themselves, it's not the units of the measurement, it is the thing that you are actually getting those measurements from. And it's not just measurements, but also observations, which is why it's called an observation unit. So it could be cars, computers, people, books, anything, planets, anything you can collect data from to create a data set. What is a variable? So this is the actual type of measurements that you're going to take. A measurement or observation that you're going to take, like height, color, age, subject. Well, that's a little ambiguous. Sorry, I'm trying to think of some different ones. Now, let's stick with these three. I think these are unambiguous variables. All right, suppose we want to compile a data set on the topic of college. What are some possible observation units that we could use? So we could use colleges themselves, but we could also do like professors, individual professors, individual students. We could do classes or courses, majors. There's all kinds of different things that you could take measurements from. But for a given data set, like you just have to pick one of these. So we could have like a data set where the rows are colleges, and then we could have variables like, you know, number of students, tuition, stuff like that. We could have a data set where the rows are professors, and then we would have variables like maybe how many classes they teach, how long they've been teaching, what subject they teach, you know. But these are all different ways of doing a data set about college. Okay, differences between a quantitative variable and a qualitative variable. So a quantitative variable, you guys know it's numbers, but it's not just that. It measures a quantity, which is an amount of something. So you can have variables that are numerical that do not measure a quantity, like zip code or phone numbers. That's not a quantity, but it's still numbers. So these would be things like height, weight, length, age. Date technically can be considered one because it's like a number of days since a standard time, but that's a little bit ambiguous, so I'll leave that one out. Yeah, things like this. So a qualitative variable is a category, or it categorizes our units, like color, gender, season, like everybody's favorite season, location, things like that. Okay, so basically the answers are going to be like words. All right, number 7. Suppose we want to compile a data set where the observation units will be colleges and universities. What are 3 possible qualitative variables that we might collect? Okay, so we could do like public versus private versus for-profit. Public-private is probably just the easiest way to do it. So that could be one variable. We could do something like what state they're in, state or country they're in. Let's see, what else could we do? We could do like the location type, like urban, rural, suburban. And you guys can probably think of some other things. Those are just the ones I thought of. What are 3 possible quantitative variables that we might collect? So number of students, number of professors, number of employees, because we have other employees besides professors, average tuition, or I guess tuition is like a set amount, right? Maybe like average amount of aid, like scholarships and stuff. Median salary of graduates, things like that. Okay, if I have 9 numbers in a random order, how do I find the median? So if they're in a random order, the first thing you have to do is put them in order. Then the middle one is the median. That's it. If you have an odd number, the middle one is the median. Just have to find it. If you have an even number of numbers, you still have to put them in order, and then take the average of the middle 2, halfway, which is the same as the halfway point between the middle 2. Okay, now we're going to actually do that. So here's a GPA of 5 students, and we want to know what's the median. So first we need to put them in order, least to greatest. So in order, the least one is 2.5, and then 2.7, 3.1, 3.3, and then 3.9. So the middle one is going to be this one, 3.1. Oops, I tried to bold it and I opened the bookmarks panel instead. So that is 3.1. Now the minimum one, just the least one, 2.5, maximum one, 3.9. And then once you have the min and the max, you can find the range. So that's going to be 3.9, the max, minus 2.5. And that's going to be, let's see, what's 39 minus 25? 14, 1.4. All right, and let's do it again with an even list. So first, I'm going to put these in order. So the lowest one is 65, then 66, 70, oh no, sorry, 68, then 70, 72, and 73. Okay, so the middle 2 are 68 and 70. So I'm going to take the average by doing 68 plus 70 divide by 2. You can do that, or you can just know that it's going to be that halfway point between those 2 numbers. So that's going to be 69. All right, so the minimum height is 65, the maximum height is 73, and of course That gives you the range. 73 minus 65 is 8. All right. Difference between how we make frequency distributions for qualitative variables versus quantitative variables. For qualitative variables, make a table where there's a row for each possible value of the variable. Then count how many answers, not how many answers, but like how many observation units had that value. Okay, so it's just every possible answer. Like if we were doing gender, for example, we'd have a female row and then a male row, and then we might have another row for like people who said something else. And then we would just count how many people went in each row. But for a quantitative variable, you can't take every possible value because there could be, like, everyone might have put a different answer, or there could be infinitely many different possibilities. So you have to make intervals. So for quantitative variables, we split all possible answers into intervals. And it's important to make sure those intervals are the same length. And then we count how many observation units had an answer or had a value within that interval. And that's how you make your histograms. I think I have to apologize because my voice is a little bit rough, but I hope it's still understandable. I want to get this video out to you, so I'm just going to go ahead and do it with a little bit rough voice. Okay, suppose we have a list of the heights of every tree on campus. What kind of charts could we use to display that information? So basically, we have a quantitative variable. So we could make a histogram, like I just mentioned. Or we could do a box plot. Those are the main two. Yeah, those are the only two I would kind of recommend making. All right, now suppose we have a list of all the trees on campus, and we have each tree classified according to its genus, like birch, pine, maple, etc., and then which building it's nearest to, like Fisher, Applebaum, etc. What kind of charts could we use to display that information? So you could do each of those two variables separately on pie charts, but you could also do a stacked bar chart or stacked column chart. Those would be the ones that we've looked at so far in this class. Explain the differences between the intervals. Okay, so they're all from 5 to 10, and then we have either parentheses, round ones, or square brackets on either side. So the number that is next to a square bracket is included in the interval, and the number that is next to the round bracket is not included. And then anything between those two numbers is included. Okay, so any number strictly between 5 and 10 is in all of the intervals. So like 5.1, 5.01, 5.001. But parentheses 510 does not include 5 or 10. Parentheses next to the 5, square bracket next to the 10 includes 10 but not 5. Bracket next to the 5 but not next to the 10 includes 5 but not 10. And finally, the one with both having the square bracket includes both 5 and 10. Okay? And the way I like to remember this is I think about the little claw machine at the arcade. If I have a claw that's shaped like a square versus a claw that's shaped more round, I think the square to me looks like I could kind of pick up more things because I could jam something in there in that square and like have it stick, versus the little round one is nothing's gonna stick in there. I know that's a dumb way of remembering it, but I think that might actually be like the real rationale behind it, because I certainly have never heard of any other rationale. So, okay, now what would be wrong with making a histogram with these bins? So 0 to 10, 10 to 20, 20 to 50, 60 to 70, and then we have various kinds of brackets and parentheses. And there are actually several things wrong with this. So there's at least 3 things that are wrong with this. I think the most obvious thing that's wrong is that these intervals are different widths. So if you were to make a histogram where the bins are different widths, I mean, your histogram should make that column that has the larger interval, it should at least make it wider, but then everybody's going to be like, well, why'd you have this big wide column like that? Why didn't you split it into the same size as the others? Like it kind of feels like you were trying to do something shady. So that's the most obvious thing that's wrong. The intervals are different widths, which could be used to mislead people. Another thing that's wrong is there's a gap. If you had any value between 50 and 60, there's actually no interval that you can put it into, because this 20 to 50 and then 60 to 70, they just skip over those numbers. So any value from above 50 up to 60 has no bin. That's a huge problem. You just didn't put that column in your histogram. And then lastly, I think there's a similar problem with some of these endpoints and those square brackets, like 10. 10 could be put into either one of these intervals. So you have to have a definite one that it goes into. You can't be like flipping a coin to decide which one you're going to put it into. And is there another one that's like that? No, the 20 is okay. Yeah, so I think those are the 3 problems. Okay, the difference between percentile and percentile rank. So a percentile is an actual data value or something that could have been a data value. Whereas a percentile rank is a percentage. So when you're making a percentile or you're finding a percentile, you start with the percentage that you're interested in, and then you find what data value would have been that far through the data set. Okay, so I'm going to write that as well. So you start with a percentage, like say 70%, and then find which, let me actually put it in terms of percentile. Then the 70th percentile is the data value, 70% of the way through the sorted list of values. Okay, versus a percentile rank, it is a percentage. So you start with a data value, the other way around, the opposite, and then find what percentage of the way through the sorted list that data value was located. Okay, so it's kind of the same, but you're doing opposite things. You're starting with the opposite piece of information. Okay, say you have a data set of the GPA of all the SU students, and you calculate that the 95th percentile is 3.88. Explain what that means. Okay, so it means that if we would sort the whole data set, sort the list of GPAs, 3.88 would be 95% of the way through, meaning from smallest to largest. So then what that actually means then is that 3.88 is as large or larger than 95% of the GPAs, and as small or smaller than the other ones, which would be 5%. Okay. Okay, say that you have a data set of the heights of all the SU students, and you calculate that the percentile rank of a person who is 5'4" is 22%. What does that mean? Okay, so that means that that person is taller than or same height as 22% of the students, and shorter than or same height as the other students, so the other 78%. All right. Finally, what is an outlier? This is a data value that is far away from the other values in the data set. And there's not really a more specific definition than that. People have come up with various ways and like tests and measurements for how to decide what is and isn't an outlier. But this is the general concept, and there's no one way of finding them that is like the correct way. People just have different opinions on how to do it. But usually there's like some pretty big gap before the outliers. There's some gap between the outliers and the rest of the data. Okay. So the rest of the questions here in part one, these were made using a data set where the observation units were sections of math classes. So sections of math classes offered over the past 4 years at SU. So this pie chart shows the semester during which each section was offered. So we had spring semester, fall semester, those are the main two. And then we also have a short winter semester and a summer semester. Most students don't take anything during those semesters, but you can do it if you want to. So which semester has the most math classes? So the biggest slice of the pie is fall. And which semester has the least? Smallest slice is winter. All right, so that's pretty easy. Now let's look at a stacked bar chart. The stacked bar chart at right shows the current math professors and the sections of math classes they have taught in the past 4 years. Okay, so the length of each person's bar and the numbers down here at the bottom, that is their number of sections. So who has taught the most sections and the least sections? So the longest bar belongs to Dr. Graham. And then the shortest bar is Professor Minori. All right, let's look at the next one. Who has taught the most 100 level sections and the least 100 level sections? So everybody's bar of their number of sections is colored according to what level those sections were. We have 100 level, 200, 300, and 400 level sections. 400 plus, because we do have some 500 level classes like independent studies. All right, so least and most 100 level sections. So I'm looking for the shortest blue bar and the longest blue bar. So the shortest one belongs to Professor, it could be either me or Steve. Yeah, me and Dr. Shire. And then the longest one is definitely Dr. Lowe. Okay. So most is Lowe, least is Jensen or Shire. Who has the least variety amongst the levels they have taught? So when we look at these bars, there's one person that only has one color, and that is Professor Bowling. He only teaches 100 level classes, so that is the least amount of variety. If I were to ask the other thing, like the most variety, I think that would be a little bit tricky to answer, like in terms of what does it mean to have variety. But at least for when I say least variety, I think hopefully you understood what that meant. Okay, who has taught the most 400 plus level sections and how many did they teach? So we're looking for 400 plus, that's yellow. So basically, who has the longest yellow bar? This is a little bit tricky to see as well, but I do think it is either Dr. Wills or it might be me, or it might be Dr. Graham. They're pretty similar. So it looks like Wills went from, this looks like about 19 up to 30, just estimating from the scale at the bottom, up to like 34. So maybe about 16. And then mine goes from 20 to, what is that, like 36? So about 16 again. And then Graham, this looks like 33 or so, up to maybe 47, like 14. Because I think it's me and Wills have done about 16 each. And you guys can just, I mean, if you want to look at this and just be like, it looks like it went over about 1.5 of these like units that are measured by the gray lines here. So about 15, that would be a fine answer, I think. just kind of an estimate. So Graham, Jensen, or Wills all did about 15. Okay. So the next chart here, the stacked bar chart above shows the current math and computer science professors and the sections of math and computer science classes they have taught in the past 4 years. I should have said sections, sorry, not classes. It's like slightly different. But anyway, this is basically the same thing, except now we're including computer science. And we have these colored according to whether they were CS classes or math classes. Who has taught the most and the fewest total sections? So most total sections is me. I am the winner. I think I've taught about 61. And the reason this is so big is because I've done a lot of independent studies and internship classes too, which you can do like multiple per semester. Okay, so most and least is, I think, Dr. Amiramatoglu is our newest professor, so that is why his is a little bit short. Okay. So next, who is the closest to teaching an equal number of math and computer science classes? So who has the best balance between those colors? I do believe it is, again, me. I'm the closest to being half and half. So I do actually teach computer science as well, and I've done a lot of computer science internships and independent studies. Yep. And then who has taught the greatest number of computer science sections? So computer science is blue, so just who has the longest blue bar? Again, I think I'm actually tied with Dr. Velaswamy. This is sort of like she actually teaches the upper level computer science classes, and I just have done a lot of internships for computer science students, really. So, yeah. Okay, and then was there one more? Nope, that was the last one for that one. Okay, and then this chart is actually different. This is not sections anymore. If you look at these numbers down here, this is total number of students. So every student that these professors have taught in the past 4 years, and then they're classified according to whether they had that student in a CS class or a math class. Okay, so who has taught the most students and how many students was it? So Graham and Lowe appear to be pretty much tied, and they're both between 600 and 700, a little bit more than halfway. But if you wanted to just estimate, like about halfway, about 650. That would be fine. Who has taught the most students in computer science classes, and how many was that? So, like I said, a lot of my CS sections have been just independent studies. So Dr. Velaswamy definitely has me beat on that front. So that's Dr. Velaswamy and about 300 students. Okay. So now some box plots. The box plots at right show the number of students in all the sections of math and computer science offered over the past 4 years, and then classified into fall and spring semesters. Okay, so we had a list of all the sections with how many students were in each section. So what was the median number of students in fall sections? So the median is going to be the center line of the box, and it looks like it's at about 14. Okay, so if we would sort all the sections by how many students they had, the middle would be 14. How many students were in the smallest 25% of sections during spring semesters? The smallest 25% is the bottom whisker, and it looks like it's going between about 0 and 2. Okay, so those are probably independent studies. How many students were in the middle 50% of sections during fall semesters? So middle 50% is the box, the whole box. So from 5 up to, what's that, about 23? All right. Which semester has more spread out class sizes, and why do you think so? So the spread out is going to be the more spread out box and whisker here is the spring for sure. The box is more spread out and the top whisker is more spread out. The bottom whisker is not quite as much, but with the other 3 parts, it's more spread out. spring has a wider, taller box and a taller, maybe I should say longer, might make sense, longer box and a longer top whisker. So the class sizes are more spread out. Okay. Number 26, the histogram at right shows the number of students in all the sections of math and computer science offered over the past 4 years. Which is the modal bin and how many sections are in it? So the modal bin is the tallest column here. So that is the, the interval from 0 to 3, including both 0 and 3. So we can just type in the interval like this. And then how many sections are in this bin? Looks like a little more than halfway from 80 to 90, maybe about 87. Say about 87 sections. Is this distribution unimodal, bimodal, multimodal, or none of these, and why? So this is a little bit up to interpretation. I think I would accept if you said unimodal, because you have this one huge peak. But it would also be okay if you guys said like trimodal, because there are these smaller peaks over here. And it's not kind of clear whether we should consider these as like actual peaks, or is this just like a little bit of random differences when compared to this big one. So I think saying either unimodal, because there's one huge peak, or saying trimodal or multimodal. There are 3 peaks, 2 or smaller, would be fine answers. It's a little bit of interpretation here. There's not like one correct way to classify it. Okay, are there any outliers in the data and where? So outliers are going to come after a gap, and yeah, there is a gap here, and then there's one section that had like a huge number of students. I think I remember when this happened, it was like one giant linear algebra section, and we couldn't figure out like a way to offer 2 sections. There is a gap, and then one section in the 39 to 42 bin. Okay, is this distribution skewed left, right, or neither? So the skew is the direction of the longer, fatter tail, if you have tails. We do sort of, if we consider this like the biggest peak, we do sort of have this very fat, bumpy, long tail over here to the right of the biggest peak, and there's nothing to the left of that peak. So yeah, this is definitely skewed right. Long, heavy tail to the right of the highest peak. Sometimes if you have multimodal data, it might not be obvious like what the tails actually are, because each peak can have its own tails. But for this one, if we use the largest peak and then look at the rest of it as a tail, that's skewed to the right. Okay, our section has 36 students, so which bin would this section go in if we were in the histogram? So 36 is right on the border of these 2 bins, and so it's going to go into the one that has the square bracket next to the 36. So that's going to be 33 to 36 bracket. Okay. The histogram above, oh, it's not above, it's actually this one on the side, shows the number of unused seats in all the sections of math and computer science offered over the past 4 years. So instead of the number of students, it's the unused seats. And that's why there's actually, you can have a negative number of unused seats. That's when you overload people into your course, like you ask the registrar to add them even though all the seats are taken already. So our class actually has a negative number of seats left because we had a cap of 35 and I let someone in over the cap. So we would actually, maybe I'll just answer this first. We would actually go in the bin that has the negative numbers. Okay, so which is the modal bin? How many sections are in it? For the tallest one, it is the same one that I just mentioned. And it has about 85 sections. So apparently most sections are filling up, or not most, this is not the majority, but it's the it's what we call a plurality. The most popular thing that can happen is that the section pretty much fills up and then maybe even gets overloaded, or maybe only has one seat left. Is this distribution unimodal, bimodal, multimodal, or none of these? I think either, if you want to say unimodal or bimodal, that would be fine. This little peak here is, I mean, I think that's really too close to the neighbors to really call that a peak. So unimodal or bimodal would be good answers. Maybe I should ask you guys to like circle these, but I didn't put it on the practice, so I guess I won't ask you that. Are there any outliers in the data, and where? No, there's no gaps, so there aren't really any outliers. I mean, there's just one section in this largest bin, but then there's a bunch of sections in the one next to it, so there are no outliers. Our section, okay, yeah, I already did that, and that was the last question. So yay, I made the video without completely losing my voice, and I hope this was helpful to you. See you in class.